Hi, I'm Alix Paultre from Aspen, and I'm here with JC Sun of Bs&T Analyzer. And well, analyzer, test and measurement, measuring things, it's all about precision, right?
Right, sure. So the BST is a specialized in measuring technique, measuring the inductive components. It's a very important part of the power systems, which right now is driven by the GaN and silicon carbide. If you take a look back to the 30 years ago, the driven technology was magnetics. The transistor was not so far. Now, 30 years later, it's come along. So, and to have the competence to evaluate the magnetic characteristic and the components and the important parts, it's a big challenge for most designers. And we are offering the opportunities, we are offering the tools to help people to enable the good design.
Well, you know, you hit the nail right on the head, JC, when you think about the aspect that analog design, inductors, magnetics, it's a science, but it's also a little bit of an art. It's a little bit of, you have some finesse. You have to really be on top of it.
Right. It's indeed, I appreciate you talk about this. A measurement is not only engineering, it's art. And especially for the magnetic materials, the people of the magnetics scientists, they are living in different world. They use different vocabulary, and it's very sensitized with their culture. For instance, in Asia, and in Japan or in China, they are very strong in the competence. And those parameters, the vocabulary that they use is very associated with the culture. And this is a little bit difficult for the engineering from the Western. And so I would like to emphasize that very much that in order to communicate in global business environment, you have to have some common vocabulary.
Understanding, yeah.
Yeah, this can be done in terms of the number. If the people measure this is reliable, then people know this, so they can communicate each other to target really the problem.
This is true, because numbers are a universal language.
Right, right. And if I take the citation of the Lord Kelvin, always said, he's always talking about if the people can measure something and put it on the number, then they know something about this. If they cannot measure and they cannot put it in a number, then their knowledge is meager and unsatisfactory.
Well put.
This is, I think it's also addressed on the people who think that if they want to have the quantifiable incremental improvement, they have to do this with measurement technique. Yeah.
Now, JC, give us an example of one of your devices that is useful in the wide-bandgap space.
Yeah. Well, in the wide-bandgap application, especially for the GaN,
high frequencies.
High frequency is a key, and people wants to looking for the materials which is suitable for high frequency. But in order to approve this, they have to do it with number, with a measuring technique, and the high frequency in the magnetic world is much more related. And according to the Snoke law, to say you have the highest BS material, lowest initial permeability, and then you extend the frequency, resonance frequency to a higher frequency. And this is, it's measurable, it's traceable, and if you use the BST analyzers to see this effect, and then you can compare this right in one sheet and among the different available commercial materials, and that is very helpful for the power design engineers. And let's see this a judgment, make the judgment according to the numbers along the same measuring principle.
Well, you know, that's something a lot of people lose sight of, but it's very important. You have to make sure the lines on the ruler are the same distance apart for everyone who's using the measurement, or else you can never get your measurements to agree. Right.
Absolutely. That's a very, very good point. The inductive components or the material measurement is a difficult task because there's none reference available so linear that people can refer We're working on the NIST, the National Instrument of
Standards.
In Boulder. We are working with the PTB in Braunschweig. We're working with Institute Reference in Torino, and they are very competent partners who are dealing with standards. The standards, it's firstly to refer the device and the measurement on one side. They're also related to instrumentation. And the third side is related also to measurement system. The measurement system actually consists of excitation, acquisition, and data processing. And therefore, it's very important that people get sensitized about this difference and to see if I have an instrument, it does not mean I can measure everything. The measurement among each other, the comparison among each other is very important. There are a lot of people threw a lot of money to do hundreds of tests. After 5 years, each get their PhD, and the value is not comparable. So the people restart again. This is something that's redundant. They can save this and just use our BST analyzers. It's more easier.
Well, and obviously the tool is important, but then you must give them support, right?
Yeah, sure.
Engineering support, guidance, help them use the tool in the best way they possibly can.
Yeah, that's true. And so we're going to do this as a much more modular way. So first of all, we easy the hardware architecture, and secondly, we educate or we inform people the existing standard and what is existing, what is not existing, what is not existing but is still important. And this differentiation, we try to do this in the Power Electronic Conference like this. And I think it's very important that people know where the competence are located. And I think that's very good to be here. So to have this a great audience, I think it's very good.
Well, I'm really glad you're here at the conference, and as I said earlier, the analog portion of the design is as critical, if not more critical, than the rest of the system. Because if you don't have clean power, good power, efficient power, you're behind the race.
Right. The wide band gap, it's critical enough, but the magnetic is more critical, and there's less people talking about. This is so difficult, and I think that's something also to bring these two technologies much more together. Next year we're going to promote BST square, which is excitation mode wave, and we use GAN. We use GAN in our measuring systems to excite the material in that way, which the application engineer looking for. And that's tries to, as we also address, we bring the results between the magnetic material scientists work with the crystalline and with together with the electrical signal. And this is our mission.
Excellent. Well, I'm really appreciating the fact that you came and took the time to chat with us. It is really an underappreciated and overlooked aspect of embedded design. So where can they go to get more information? So
just check our website, the powerlosstester.de. You will find this and be happy to answer the question.
Excellent. Hey, JC, thank you so much for taking the time to be with us. I really appreciate it.